Welcome back, Focus learners. This explainer was made by Forge College, and man, are we excited to continue our journey through the Solidity from Zero track. So, in our last lesson, the capstone assembly, we built a pretty comprehensive smart contract using data types, structs, and mappings, right? Basically, we constructed the walls and the internal rooms of our smart contract building. But a building without doors isn't exactly useful, is it? So today, we're moving from building those static data structures to actually adding functional doors. Let's dive right into function visibility fundamentals. Here is the blueprint for today's explainer. First, building your smart contract. Second, the 4 function doors. Third, public versus external visibilities. Then internal versus private visibilities, followed by a token contract example, and finally, keys to the castle. Okay, let's dive into this. Section 1, building your smart contract, the setup. So here's the catch with that rock-solid foundation you just built. A smart contract building just isn't functional without doors to control access. Function visibility acts as your ultimate gatekeeper. It determines exactly who gets to interact with all those beautiful data shapes you've so carefully constructed. You know, who gets to read them, who gets to change them, and maybe most importantly, who gets locked out in the cold. But hey, before we hang a single door, we really need to talk about the ABI, the Application Binary Interface. I want you to think of the ABI as the public floor plan of your smart contract. It literally shows anyone looking at your contract exactly which doors are visible and accessible from the outside world. If you expose a function here, you are basically putting up a giant neon sign inviting external interactions. And as any good architect knows, external interactions, well, they require some serious validation and security. All right, moving on to Section 2, the 4 function doors, the blueprint. So we have 4 distinct visibility levels we'll be installing today to control caller access. We've got public doors, external doors, internal doors, and private doors. And trust me, each one serves a highly specific purpose in your contract's overall architecture. Let's step outside for a second. Section 3, public versus external visibilities, street-facing doors. Now notice the core distinction here. Public visibility, that's a door with massive street-facing signage. Literally anyone outside can enter, and your internal staff can use it easily from the inside too. No problem. External visibility, however, is strictly for outside visitors. If your internal code tries to use an external door, they can't just casually turn the handle. They have to literally reach out a window and poke the outside handle with a weird broomstick, using this really clunky syntax like this.some external function. It's awkward, it's slightly embarrassing, and yeah, it actually costs you extra gas, so don't do that. Let's head behind the scenes now. Section 4, internal versus private visibilities, staff-only doors. Okay, so here we're comparing internal and private visibilities. Internal doors are kind of like shared corridors. They connect neighboring rooms and, crucially, child contracts if you happen to be using inheritance. This is what gives your smart contract that awesome extensibility. Private doors, on the other hand, are strictly staff-only for that specific room. Think of it as your top-secret broom closet. It is entirely encapsulated, totally invisible even to sibling or child contracts. Private is absolutely perfect when you want to lock down internal housekeeping logic that you might want to completely rewrite later, without breaking anything else. And this brilliantly illustrates what we've been talking about. Let's look at this master cheat sheet. Public and external modifiers expose your functions right on the ABI, inviting external accounts and other contracts to interact. Meanwhile, internal and private, those are kept strictly off the ABI. They are safely hidden away for your contract's own internal operations and little helpers. Let's look at the technical mechanics under the hood for a sec. ABI expose doors, so public and external, use EVM function selectors. Now these are dispatched at runtime, which means they cost precious gas. But our hidden doors, internal and private, those are resolved statically by the compiler as highly efficient compile time jumps. So keeping functions internal or private isn't just a security best practice, it literally saves you gas and prevents accidental external discovery. It's a total win-win. Let's make this concrete. Section 5, token contract example, the construction site. All right, let's walk through our architectural decisions step by step using a token contract, very similar to the one from your capstone. Step 1, reading balances. You want the whole world to see these, right? So you use a public or external view door. Step 2, transferring tokens. This is an action specifically initiated by users, so it's a perfect candidate for an external door, which actually saves a bit of gas for those outside callers. Step 3, validating preconditions. Things like making sure a user has enough balance or checking for safe arithmetic. That logic, that belongs firmly behind an internal or private door. That is strictly staff-only business.
So if you take away one thing, make it this: use your public entry points sparingly. You really want to minimize your public surface area to keep your contract interface as stable and maintainable as possible. And for the public doors you do decide to install, always remember to add authorization locks. Something like a require statement checking that the message sender is the owner or at least an authorized user. Don't just leave the front door wide open for anybody to wander in.
Section 6, Keys to the Castle, the handover. Let's do a quick, punchy recap to really lock this into memory. Public, it's right there on the ABI, open to absolutely everyone. External, also on the ABI, but strictly for outside visitors only. Internal, hidden completely from the ABI, perfect for inheritable helpers. And private, completely hidden, strictly local for super tight encapsulation. As you design your functions moving forward, you really need to ask yourself these 3 crucial questions. First, who actually needs to call this thing? Second, will derived child contracts need access to it in the future? And third, will I need to change this implementation later without breaking the public interface? Honestly, just answering these 3 things will immediately tell you exactly which of the 4 doors you need to install. And that brings us to a final, somewhat provocative thought. Now that you've installed all the right doors, how will these specific visibilities change the way we carry data, like our function parameters, through our contract's memory model? Well, that is exactly what we're going to be tackling in our next lesson within the Functions and Modifiers in Solidity course. To master that and to dive into even more amazing Web3 topics, make sure you visit the website forge.college. This explainer was made by Forge College. I am so incredibly glad you joined me today, and I'll catch you in the next one.